ordering decimals. So the first one they want us to order from least to greatest. So least is smallest. So we're going from small to large on this one. Now I'm going to write these decimals out vertically so that I can work with them. So I notice this has two numbers after the decimal. This one has 1, 2, 3. This one has 1, 2, 3, 4, and this one has 1. So the greatest number of numbers after the decimal is 4. So I want to make them all have 4 numbers after the decimal. So the first one only has 2 numbers. So I have to add 2 zeros. You just add zeros on the end. I want them to have 4 for this particular problem because the one with the most number of decimals had 4. 5.1761, that one already had 4, and 7.1123. Okay, we want the smallest number. The reason I have them have the same number after the decimals is because literally at that point, you can literally just, I can get this to work. You can literally take the decimal away. Like this. So this is now how you look at those numbers. 71,800, 71,080, 51,776, and 71,000. Well, the smallest number is 51,000. So that belonged to the 5.1761. You want to make them look like they were originally. And then we're going from least to greatest, so I'm going to put a less than symbol. Okay, the next one is 71,000. So that was the fourth one on the list, so that 7.1 is less than 71,800 or 71,080. 71,080 is the smallest. So that was the second number on the list, so that's 7.108. And then that means the first one is the greatest one, so 7.18. So now you've got them smallest to greatest. Okay, least, that's small to big. Okay, we've got, again, it looks like the largest number of numbers after the decimal is 4. So I'm going to make them all have 4. 1.3562, 3.6000, 3.6100. If they don't have 4 numbers after the decimal, you just have to go ahead and put a 0 at the end, because if you have them have the same number of numbers after the decimal, then you can actually, oops, what just happened? Okay, sorry. That was a little bit larger than I planned on it being. Got reset somehow. Then you can take the decimals away. So we're starting with the smallest number first. So that would definitely be 13,000 because these are all 36,000s. So that is the first number. 1.3562 is less than. Okay, these are all 36,000. So we actually can cross the 36 out to look at the numbers after that. So 0, 100, or 10. Well, obviously the smaller number is 0. So the second number on the list, 3.6, comes next. Out of 110, 10 is smaller, so that's the last number on the list, 3.601. And so that means the third number on the list is the largest, 3.6. Third number on the list is 3.61. Sorry about that. Okay. Next one, least to greatest. You've always got to read that because sometimes they'll switch that up on you. In this particular exercise they didn't, but sometimes they will. So we're going from small to big. Sorry about that. Okay, looks like it's 4 again. 1, 2, 3, 4. So 1.7042, 1.7000, 1.7400, and 2.3170. Once you make them have the same number of numbers after the decimal, then you can take the decimal away. So obviously the smaller ones are going to be the ones that start with the number 1. So I'm going to just take out the 17s because they all start with 17. Okay, so out of those, I've got 42, 0, or 400. Well, the 0 is the smallest, so that means the second number on the list comes first, 1.7. And then 42 or 400, the 42 is smaller, so that's the first number on the list. And then that means the third number on the list comes next. And the one that began with a 2, I forgot to erase that decimal point, sorry about that. 2.3170 is actually the greatest number on the list, and it's not a. You have to make it look like the original problem, and it didn't have that ending 0. So that's the correct way to write that.